Welcome to True Projects. In this video, we are going to explain about the project that is a universal and efficient multi-model smart contract vulnerability detection framework for big data. So before getting into the execution, first let us understand what is this project about. Smart contracts. They are like automated programs that run on blockchain networks and they can manage transactions, keep records or perform tasks automatically without needing a central authority. Because of their transparency and tamper proof nature, they are widely used in areas like digital finance, logistics, managing assets, and tracking supply chains. However, since these contracts are often deal with large amount of money, even a small mistake in the code can have serious consequences. Hackers can exploit these mistakes to steal funds or access sensitive information. A famous example is the DAO hack in 2016, where attackers exploited a vulnerability in a smart contract and stole over $60 million. In fact, hundreds of blockchain attacks have caused billions in losses. This shows how important it is to have effective and reliable methods to detect vulnerabilities in smart contracts before they are deployed. And there are several methods that are already used to find vulnerabilities in the smart contracts, like symbolic execution, fuzz testing, and formal verification. Symbolic execution tries to explore all the possible paths in contract codes. Fuzz testing feeds random or unexpected inputs to see if it breaks, and formal verification uses strict mathematical proofs to check correctness. While these methods can catch some problems, they have major drawbacks. They usually need experts who understand blockchain and smart contracts very well. They can miss important cases like incomplete test coverage or too many paths to check. And they can often can't keep up with the new or changing types of vulnerabilities. So recently, machine learning approaches have been applied to smart contracts, security, and they can improve detection. However, most of these focus on only one type of features or one type of contract, which makes them less flexible and harder to use on different contracts. Because of these limitations, finding a method that is accurate, adaptable, and efficient for detecting vulnerabilities in smart contracts is still a big challenge in blockchain security research. So, to overcome from all such issues, the proposed system is designed to identify vulnerabilities in smart contracts and blockchain platforms using a deep learning based multimodal approach. Smart contracts, they are self executing programs that manage transactions and data automatically. However, like any software, they also can contain coding errors or flaws which attackers can exploit to manipulate transactions or steal the digital assets. As we know that traditional methods for detecting vulnerabilities, such as symbolic executions and fuzzy testing, have significant limitations. They often require specialized knowledge, may not handle complex or unknown vulnerabilities effectively, and they can miss critical security issues. So by using deep learning, the proposed system, it can automatically learn patterns from the different types of smart contract data, making vulnerability detection more accurate, efficient, and adaptable. And here the system improves vulnerability detection by using multi-model deep learning model, which combines the three powerful architectures that is BiLSTM, Efficient Net, and Transformer. Each of these models helps the system understand different aspects of a smart contract, such as the order of the code, structural patterns, and contextual information. And the smart bug dataset, that is the smart contract data, comes from the smart bugs dataset, specifically the word to vec feature set, where the source code is transformed into numerical vectors. This transformation helps the model to understand the meaning and the relationship within the code, while the BiLSTM model is used as a baseline to analyze sequence of the code. The multi-model combines multiple perspectives, sequence, structure, and the context, so it can detect vulnerabilities more accurately and effectively than using a single model alone. And here, to further improve the performance of this project, that is to make the multi-model smart contract vulnerability detection even better, two hybrid models are incorporated by adding the CNN2D networks. So the CNN2D is a type of neural network that is very good at automatically learning important features from the raw data. This means it can identify patterns and characteristics in the smart contract data without needing manual feature engineering, making the system more accurate and effective at detecting vulnerabilities. And here, the first hybrid model, that is CNN2D, is combined with BiLSTM, EfficientNet, and Transformer. This combination allows the system to learn from smart contracts in multiple ways. So BiLSTM captures the sequence of the code, EfficientNet extracts structural patterns, Transformer understands contextual relationships, and CNN2D automatically identifies important features from the raw data. Together, these models help the system to detect vulnerabilities more accurately. And in the second hybrid model, BiGRU is replaced with BiLSTM in the architecture, resulting in the model composed of CNN2D, BiGRU, EfficientNet, and Transformer. This change provides an alternative way to analyze sequential information in the code. Both hybrid models show that adding CNN2D improves the system's ability to learn complex patterns and enhances the overall performance of the smart contract vulnerability detection compared to the original multi-model. Moving on, so these are the modules of this project. So coming to the first module, this module allows a new user to create an account on the application. Signing up ensures that only authorized users can access the system and its features. Then we have user login. So this module enables existing users to log in into the system using their credentials. It provides secure access to the application functionalities. Then we have load and process SmartBug dataset. In this module, the user can load the SmartBug dataset, which contains smart contract source code, and the system applies word2vec to convert the code into numeric features, that is n-gram vectors, that can be understand by machine learning models, that can be understood by machine learning models, and the extracted features are split into training and testing sets to prepare for model training and evaluation. Then comes training the multi-model algorithms. In this stage, we will be training various machine learning models, including existing algorithms and the proposed multi-model and the hybrid extensions. Then comes detecting vulnerabilities. So in this module, we will be uploading new smart contract dataset. The system applies word2vec to extract numeric features from the uploaded code and then uses the trained extension model to determine whether the smart contract is vulnerable or invulnerable. And to execute this project, we need two kinds of requirements, which are hardware and software. In hardware, we need operating system of Windows, processor of 5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. Software requirements are application of Python, front-end framework of Flask, database of SQLite 3, and front-end technologies are HTML, CSS, JavaScript, and Bootstrap 4. So these are the requirements, and this is the overview of the project. Now let's execute it. To execute, open the code folder that contains source code files. So these are the source code files, and let's understand. So this is a dataset folder which is used in this project to train the models. So let's open it. And this is the SmartBug dataset that we have used. Let's open. So this is the dataset that we have used it for training. And here we have multiple features. That is address, tools, lines, how many number of lines are there, and NB vulnerabilities and source code. And here we have labels, that is a target column that we will be using for prediction. And this is the test dataset that we will be using in the front end. Get back. And this is the model folder in which we have algorithm information that will be loaded into the project code during runtime of the application. And here we have static folder in which we have files related to CSS, JavaScript, and Bootstrap files, which are important for the project's visual appeal. And here we have templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. And here we have app.py file. So this .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in HTML templates. And here we have database file that is used to store the database, that is used to store the data. And here we have Python source code file for the transform. So this is all about the code folder. Now let's execute it. To execute, first we need to open the command prompt. So open command, first copy the path of the code folder from the address bar of the file explorer. So copy it. Now open the command prompt. So it is open. Give the command cd, give the space, paste the copied path, click on enter. So here you can see current directory is changed to the code folder's path. Now compile app.py file. So give the command python space app.py and click on enter. So this command will execute the app.py file. and it will execute the Python script and check for any syntax errors or logical issues. And after running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So let's wait for a while. File is being compiled. So application is hosted at this address. So this is the local host and this 5000 is the port. Now copy this local link provided by the Flask framework and paste it into any web browser. I'm copying the link and I prefer Google Chrome, so I will paste it in that. Paste the link here and click on enter. So this is the web page of the project, which is displayed in the browser, and this is developed using Flask framework. So to start executing, we need to sign up first. So click on new user sign up here and enter all the required details to create an account. I have already created account, so I will directly log in. Click on user login and provide your username and the password. Now click on login. So we have logged in successfully and redirected to prediction page. So first we need to upload the SmartBug dataset for training the machine learning, that is the multi-model algorithms, that are the deep learning models. So here you can see an option called choose file set. We need to click on that for uploading the dataset. So let's click on choose files, select the SmartBug dataset, click on open. And here you can see it is loaded. Now click on upload dataset. So this data set will be pre-processed and then it will be used for training purpose. So just wait for a while. So here we got the data set contents. So here we have first 100 records. So these are the first 100 records of the data set. So these are the first 100 records. So here you can see the unnamed column, address, tools, lines, and NB vulnerabilities. And here total we have 100 records, 5 columns, CSV format, and these are the smart contracts. So this data set is in the CSV format. And here you can click on back to dashboard or either you can train the models. So first let's train the models. Click on train models. And here you can see models have been trained. So these are the different models that we have trained. And here we have their evaluation metrics. After training, existing bialistic model, here are the metrics, that is 88%, 88.1, 88.54, and 88.3. And this is the proposed model, that is 90.3, 90.02, 90.89.71, and 89.86. So similarly, we have for the two extension models, you can see it has achieved 91.1% accuracy and it is higher than the proposed model and existing model. So similarly, here also we have the related metrics. Similarly, here also we have, and if you observe, the extension 2 has the highest accuracy than all the above three models. And here we have performance evaluation, that is visualizations. This is the confusion matrix prediction. And here we have all the algorithms performance graph. Here on x-axis, we have all the models that we have trained, and on y-axis, we have the related performance metrics. And here each color represents one type of metric. So blue color represents accuracy, and this orange represents FN score, green represents precision, red represents recall. So here you can see all the evaluation metrics. Now let's detect vulnerabilities. And here you can see the confusion matrix performance evaluation. So let's detect vulnerabilities. Click on detect vulnerabilities. And here we need to upload a file. So the file requirements are it should be in the CSV format and it should not exceed 10 MB. And first column should contain smart contract code and ensure that it is proper encoded in the UTF recommended format. So let's click on choose file and select the test data. Click on open and now click on analyze vulnerabilities. So here we got the smart contract vulnerability prediction. So here total contracts analyzed are 10. Out of that, 4 vulnerabilities are found and 6 safe contracts are found. And here you can see 40% is of risk level. So here we have individual smart code. So this is the first smart code. So this is a smart code you can see on text box. And here you can see security status. It is vulnerability detected and it is 100% confident. Similarly, for the second smart contract that we have given, it is predicting to be vulnerability with the 100%. For the third one, we have no vulnerability detected with the 73% confidence score. Accordingly, for all the smart contracts that we have given, it is predicting the vulnerability of the smart contract with the confidence level. And here you can see 40% is the risk level. And here you can see 6 contracts are safe and 4 vulnerabilities are found. Now click on logout. So this project, it provides a reliable way to check smart contracts for potential security issues before they are used. By analyzing contracts from multiple perspectives, the system can accurately identify weaknesses, helping prevent financial losses and making blockchain applications safer and more trustworthy. So this is all about the project.
Thank you for watching video. For more projects please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.